Hello. Okay, so I wanted to do something special when I start. So I learned in the last month how to do flip backward on the stage. So I'm good now, but I need you to count from 5 to 0 with me, okay? So, and then we'll do it. 5, 4, 3, 2, 1. No, I'm just kidding. I will not do it. I think it's dangerous, but maybe after that. But let's learn some React Native, okay? So before I start, I want to know a little bit who are you here in the audience. So raising your hand, who is here a backend developer? Some backend developers, nice to meet you. Web developers, which is not developing mobile apps, okay. React Native developers, yeah, I see some. Is there someone that already has an app on the store or Google Play? Nice, okay. Okay, so before I start, and now I know you, I asked you this question because I want to feed this information especially for you, even if you're a backend developer, web developer, or React Native developer who's supposed to enjoy this lecture and understand it, maybe in different levels. So I will tell you a little bit who I am after Benji told most of the stuff. I'm a full-stack freelance developer. I have an experience almost 12 years of software development. I'm one of the creators of Making Software podcast. Who here in the podcast? Nice, nice to. If you are not hearing it, find it on Google and hear it after that. In addition, I'm proud to be OFEC alumni. It's the development unit of the Air Force. Someone here from OFEC also? Only one. Okay. And I don't want you to say that I'm not sensitive, so I'm happy husband to Olga, my wife, and father to my dog, June. Here's the, you almost don't see her because of the colors. Okay, so I will tell you what are the stuff that I want you to learn in this lecture before we start. As I said, first of all, my purpose is to show you how the mobile world looks in a very high level, and then where React Native stands inside it. But the most important stuff in the lecture, I want you to understand how the architecture of React Native is built. It's called the bridge, and what is the new architecture of React Native, which is called Project Fabric. If you will get something from this part of the lecture, so I did my job. Okay, so today, I didn't put all the logos, so don't worry. Today, if you want to develop a mobile app, if you want to develop a native mobile app, so Apple or Android, you need to know Swift, Objective-C, Java, or Kotlin. So you need to know 2 languages. You need more resources, so it's very hard, but the performance will be better for sure. If you want to develop a hybrid app, and you're only a web developer and know JavaScript, CSS, and HTML, so you have Cordova, Ionic, you have progressive web apps, so you can develop a mobile app, but it will be, generally says, like a browser inside a mobile app. It will not work exactly like you developed it in a native way. The other option, I called it native-like. This is where React Native stands, as you see, and also Flutter of Google, and Xamarin, and NativeScript, which is not here. Those are the native-like platforms. Those are the platforms that you can know JavaScript, HTML, CSS, and maybe React in React Native case, and then you have native app. It's like you wrote native code by yourself. Most of the people, some of the people I guess that are here and even developers of React Native, take it as a magic. But it's not a real magic. It has a whole architecture behind it, and I want to explain you about it. So let's start from the beginning. Let's put the native side out and talk about only the Cordova side and React Native so we understand how it's built. If we take a Cordova app, you see the blue side. So all the components that you write inside the HTML will get inside a native UI view. This is how it's called. So like I said, it's like a browser inside a mobile app. The performance will be different, everything will be a little bit different, but it will look like an app. Maybe for some simple cases and basic cases, it will look good for you. But if you need better performance using the hardware of the mobile device, maybe some animations, you will feel the difference. So in React Native, it works a little bit different. It's not, a lot of people think that you write JavaScript code and it compiles directly to the native code. But this is not exactly how it happens. What happens here is you have in the React Native core a pre-made components for you. For example, the text component you have native text component, image component, you have image native components. So like you see here, if you wrote the input text in the React Native side, you will have a UI text. In the iOS side or in the Android, it will be text. Same with image and button. So it's almost like you wrote a native code by yourself. So let's see some code. It's the same but different. I'm not sure if this meme is funny. OK, so this is the code that you write in React Native. This is how it looks. As you see here, you have here, this is supposed to show on the screen a view with an image and a text. So you import components from React Native in the JavaScript side. You import the view, the image, and the text. You write some styles. And then you will have a mobile app that shows it with native components. On the other side, someone else already did the job for you. In Objective-C, this is an example, don't be scared, of the code that's already written in Objective-C. They wrote a code that implements the image. The RCT, by the way, is a shortcut to React. And this is how it will look implementing the bridge. You see the word bridge a lot here. You will see it after that also. So if you want to implement a native component, this is how it looks. But don't worry, the text, the views, and some other components already pre-implemented for you. So on the other side, if you look at the project pane, this is how it will look. You will have all the files inside an Xcode project if you'll open your app as an Xcode project. So you will see everything there, and you don't need to implement anything. Just you need to know JavaScript and React Native library, of course. OK, so if you want, but let's say you want to write a calendar component. You don't have it inside React Native library, and you need a calendar component that will work on the mobile side and will be like you wrote a native code. So in this case, you need to write an actual native code. But don't worry, the React Native library is awesome, and a lot of people already open sourced most of the libraries that you need for you, but you can do it also by yourself. Generally, you can just export a module, you can create a method and some other code. This is just a simple example. Here we have an add event function that we create that gets a name and a location in the native side, and then the way it will look in the JavaScript side is like that. You will do import to the calendar manager. You will use calendar manager add event writing only JavaScript, and then you will see the calendar. Very simple, and you know only JavaScript. But this is how it works behind the scenes. So let's deep dive a little more about the bridge. After we understand that you write JavaScript code, and it's actually mapped to native components, but not compiled to them. So the bridge, like I said, is not a magic. It's a whole architecture. So how it works in the high level. If we divide the communication between the native side and the JavaScript side, so we have two different threads inside the app. One thread is the JavaScript thread. The other thread is the native thread. They want to talk between themselves, but the JavaScript is written in one language, and the native side can be maybe Swift or Java or something else, and you want to a direct communication between them. So the bridge job is to take care of this communication. How the bridge does it? Through JSON messages. You can send JSON message from the JavaScript side to the native side through the bridge that said, create this view with this color, with this data. For example, if you create a login screen with input and buttons and all the other stuff you have in a login screen, you just send it by commands. It's like if you, like I said, backend developers. So in the backend side, if you have a Java service and you have a PHP service that wants to communicate with each other, so they can't communicate with each other because they have different memory, they are not aware to each other. So a nice pattern to use is a message broker. It's like a queue that knows how to get JSON messages or XML or other formats. So the Java service can send the JSON to the queue. The queue will hold it. The PHP will take this message, and because it knows the format, it will know what to do in his side. So it's exactly the same here in React Native to understand the concept. So this is an example. If you will try to trace the React Native app on the way it communicates between JavaScript and native and vice versa, this is an example. You see, the UI manager create the view. You can see your text, view, raw text, which is a label of hello world, and the styles, and it's also do the set children, parent. So all the UI tree is being set through JSON messages using the bridge. So what is this bridge that I'm talking about so much? So generally, the bridge is built in, I think, 60% C and C++. The other part is assembler. Someone here is an assembler developer? I guessed. COBOL? Oh, yeah? You're kidding. OK. Get out. No, just kidding. OK, so it's built mostly in C and C++. And also, it uses the magic on it is JavaScript engines. JavaScript engines are engines that let you speak from JavaScript code to machine code, to like C code, C++ code. Anyone here uses Google Chrome? In raising your hand? Only him. The other uses Internet Explorer, I'm sure. OK. OK, so Google Chrome using the V8 engine. Did anyone heard about it? Yeah, so the V8 engine is an engine that you can speak from JavaScript to C++ side. All your browser, almost all of it, is written on C and C++. It's not JavaScript. So sometimes, if you write a console log, which is a very basic command that all of us know, you go to the browser, you click on inspect, and you write just console log without anything. So you will see there native function if you click enter only on console log, because this native function is a C++ function that the JavaScript has a reference to it, and it can talk with it. But it's not JavaScript directly. So the bridge using JavaScript core, not V8. It uses V8 only for debugging. And why they decided on the start to use JavaScript core? Because JavaScript core is built in for Apple, not for Android. So they thought it will work better using JavaScript core engine, which is kind of a parallel engine to the V8. So if you're using React Native and you see that your Android app takes more time to launch, it's because the Android side is bundling all the JavaScript core code because it's not part of it. So it's not because it's Android. It's just because it's bundling all the JavaScript core library. So now we understand generally what is the bridge. We understand that JavaScript code is mapped to a native code. But I want you to actually understand what happens when you take an app, let's say Instagram, if you use it, and you click on the icon, and then the app opens. So a lot of stuff happens in this process. So I want you to understand actually what happens here. So to understand it, you need to know, first of all, a couple of terms. First term is the UI manager. The UI manager is the thread, like I said, the native thread on the native side. He needs to take care to all the Android and iOS side. He needs to create the UI, to refresh the UI, to put the data inside. This is his general job to do. The other part is the JavaScript thread. The JavaScript thread holding all your app, like you have a web app, so all the React components are there, all the logic is there, everything is there. It's like a React app inside the JavaScript thread. Everything is there, so you have the reconciliation mechanism, everything is there. So as you see in the graph, you have the JavaScript using React, and the JS is the JavaScript core. It can use the engine. This is the JavaScript thread. The other very interesting thread is the shadow thread. The shadow thread part is to take care of the layout, because after all, it's a mobile app using the mobile operating system. It's not a browser, it's not a web app. So when you write CSS, as you saw before that we send the CSS through the bridge, so the mobile side do not understand what it means. It's not understand flex-based CSS. So it needs someone to translate it to his language. So what it does, first of all, it builds the shadow tree, the shadow thread, with parent node, all your app, like input that has checkbox that has I don't know what inside, in a tree that you don't see in the UI behind the scenes. This way, it can also refresh in the React way only the parts that change after that, and not all the tree. And it uses an engine called Yoga. Anyone heard about Yoga engine? Did anyone saw Yoga on the pods of the React Native app and just copy-paste it? I'm sure. Yeah, I did it, I think, a year or two ago. So Yoga is an engine that Facebook wrote that's supposed to translate the CSS into the real mobile layout, to know what is the width, what is the height, what are the spaces. This is what Yoga will do. And then the UI part, the native part, can show you the app. So let's see a full process, how it works. Okay, so I pressed on, let's say, an Instagram icon. So now the UI manager do its job. It's loading all the native side of the app, all the modules that map, the text, the image, the view, everything that I told you before. It can be 100 models that maybe I need only part of them. It's a clue for later. And also, now it's telling the JavaScript thread, hey, I'm ready. Now you can work. So the JavaScript thread loading all the JavaScript app into one file called main.bundle.js. If you open the command line while the React app is launching and you see 90%, 100%, you will see the MainBundleJS. This is the file that everything is loaded inside it. Then it tells the bridge, like we saw before, hey, I'm ready. So now I need you to create the views and put the parents, and this is the order of the app that I want. Let's say we have a welcome window, so I need to put a text and an input, and I don't know, maybe checkbox and an image. So I'll put everything through the bridge. Now the bridge will use the shadow node that we discussed about to organize the tree, how the UI looks now. It will use the yoga layout to calculate everything. And then it will tell the UI manager, now you can show the app. And now you will see the Instagram app in front of your face. So this is the whole process that happens only when you click on the icon and the app opens. So who thinks it's a cool process and it works great after you heard it? Okay, not a lot of people, or you are shy, I'm not sure. But yeah, it's a very nice process, and it has the advantages that we'll talk now, like it's native-like experience, and you write only JavaScript code. The actions are async. I wanted to tell you also this. The bridge, all the actions that you do through the bridge are batched. Like every 60 or 100 millisecond, all the actions that you did in the UI, on the JavaScript side, on the native side, and vice versa, is passed through the bridge, but asynchronically. It's not synchronically. So it's not blocking the UI, but what if I want to do some synchronized action? We'll talk about it in the next slide. In addition to that, in most cases, I will get a good performance. And a lot of companies today use React Native and enjoy it, but some companies felt the disadvantage of this library, and now we'll talk about it. So React Native also has some disadvantages. It exists, I think, like 4 years, and since then they learned a lot of stuff. The Facebook Marketplace app is written fully in React Native, an app that millions of people using. Part of Instagram, written in React Native. A big part of Stripe, using React Native. Bloomberg Business, all the app is React Native, and Wix using it, and a lot of other companies that I can mention. But there are also some disadvantages that prevented them from doing some stuff that they wanted to do. First, the async is an advantage, but it's also a disadvantage. Because let's take a case that I have an app with 100 elements, and I see only 5 elements in the screen, and I need to scroll to see the others. So in React Native, what I will do, I will scroll, and now the UI will not be blocked, so the scroll will happen, but now I need to get the data of the other 5 elements. So this will happen to the JavaScript side with the bridge asynchronically. So maybe it will not happen when I want it to happen. So I can scroll, and then I will see a flicking screen. I will see a white screen instead of getting a smooth mobile app. And this is kind of one of the edge cases that people didn't like. And you have a lot more from these cases. In addition, we talked about 3 threads, the native thread, the JavaScript thread, and the shadow thread. So it's good for this architecture, but it's a lot of threads. I cannot use a shared memory. I need to pass the data by copies. If I want to upload an image and then do something with this image, I need to upload all this image data and copy it between the bridge in JSON messages. If I could have a shared memory, it will be a lot faster because I had a reference to it. In addition, I need to load all the native modules when I launch the app. If I have 100 native modules and I need only 2, I will need to load all of them because the UI manager will need to map them before. So the React Native core and the library and the repository is very heavy. If you want to contribute to it, it's a lot harder for you as a developer because it's like, I'm not sure if a monster, but it's a big repository. It's very hard to get into it, to add stuff. If you do a pull request, it will take the Facebook team a lot of time to fix it because they need to check a lot of stuff there. So all those stuff are some disadvantages in React Native that needs to be fixed. So now we are going to talk about Project Fabric. So Sophie Alpert, she was the, I think was the leader of a React team in Facebook, but I think it's not true in the last couple of months. So she wrote a post in the React blog called State of React Native 2018, and she talked about the story that brought them to the decision to change all the architecture. So she said all the stuff that I mentioned before. She said we want to give the option to do sync operation. We want to give the user the option to give high priority to specific UI threads and low priority to others. We want the launch time to be lower. We want the performance while the app works will be faster. We want other developers that want to develop mobile apps which are native-like have a better experience in the development and in the user experience. So currently, they call it Project Fabric. It's still not the official name, but this is the name they use for now. So if this was the architecture that we talked until now, this is the current architecture that, by the way, still exists. The change wasn't made yet. So we had the JavaScript side with React, JavaScript core. We had the native side, the blue side, and the bridge between them that can use ShadowRed to create everything. JSON messages were passed asynchronically. And you have the native modules that already made for you and implemented. You just need to write JavaScript code. So don't be scared. I will explain about everything. But this is the new architecture of React Native, of Project Fabric. So as you see, the React side and JavaScript side, almost the same. The native, almost in the same place. But some stuff changed. The bridge is not here anymore. The bridge is removed. Now we have something else to make the glue between the JavaScript side and the native side. We have the JSI. The JSI is the real new magic of the architecture. And then we have Fabric and Turbo models, which also can know how to connect between the native and JavaScript side. Now I will explain you how it happens. So first of all, just as a side note, if you will look on Google React Native Library, you will get to the repository. You can find in the repository in React Commons since version, I think, 0.59. You can find all the new changes that I'm going to talk about. It's not released yet. You can actually see it before it's released. Some of them are release candidates, maybe. And the JSI is fully released, but without a full documentation. So you can find it in React Commons. You can see the code of Fabric, of JSI, Yoga. You can see everything. This is just a side note. So let's explain all the terms. So erase all the terms that you knew before, the UI manager, the JavaScript thread, the shadow thread. They still exist now, but they will change. Now, those are the new terms that you need to know. First term is the JavaScript interface, JSI. This is the interface that lets you speak between JavaScript and native instead of the bridge. So now they will be really aware to each other. They will share the same memory. So how it has been done, you need to write, instead of writing the native modules that existed before in React Native, now they're writing native modules that called turbo modules that we'll talk after that export a native object. Okay, this is called a host object that the JavaScript object can use as a reference. It's not a copy, it's a reference. If I want to do something which is not so smart now, but let's see if it will work. If you will go to the, like I said, console, you will go to the Chrome browser, and then you write console.log. So now, let's see. You see, when I write console.log in the browser, what I see here is not a JavaScript function. You have a native code, because it's C++ code that's written behind it in the internals of the browser. So same idea here. Same idea here. Now they said, OK, we will export a native function as a reference in JavaScript. And JavaScript can call directly to the native UI and change things and send everything through it instead of copies and sharing memory. The performance will be a lot better due to it. So this is the JSI. The Fabric uses the JSI Fabric is supposed to replace the UI manager that we discussed about before. This is supposed to create all the UI of the Android or Apple and show everything in the final step. It will take care of all the UI operations. I put you an example. I'm not sure if you see it. This is part of the code in GitHub. You have create node, clone node, append child, everything, creating the shadow node, and the UI is there. Turbo modules. Turbo modules supposed to replace the native modules. Turbo modules, one of the biggest idea besides being a reference to native objects. So they are lazy loaded. Lazy loaded. It means you load them only when you use them. So now, instead of loading in the lunchtime like 100 modules, if you use only 2 or 3, you will load only 2 or 3 modules. Imagine how the performance can be better with this simple idea. Another tool, it's called Cochin. It's not part of the code. Cochin idea is to make the JavaScript single source of truth. What does it mean? You can create in the JavaScript side static types of all your interface of the data that you want to pass from the JavaScript side to the native. So instead, the native side and JavaScript side doing some validation test and like wasting performance on it, the native side is already aware to the JavaScript models that you pass between the sides. And then the performance will also be better, and the code even will be safer, because everything is configured. The last stuff that I want to talk about here in this part, it's not a new code, but it's a new play that they do. It's called link core. Link core means that they want to take the React Native library. By the way, they already did part of this process this year, and they will finish it maybe next year. They take in React Native library and take in a couple of the libraries there outside. Async storage, slider, image iOS picker, date picker, a lot of libraries they take in outside. Why? First of all, the lunchtime will be better. Secondly, it will be easier to resolve pull requests and fix stuff and find stuff and what's related to what. In addition, now the community of the developers can contribute to the libraries a lot easier, because now those are small libraries. So this is how it looks, for example. Those are 3 libraries that I wanted to show you, like React Native Slider, React Native Image Editor, and React Native Async Storage. All of them, since the last month, since version 0.59, are new libraries in GitHub repository. They are not part of React Native anymore. And this is the link core, to make the core a lot leaner. So let's discuss again on the process that we talked before. When we want to open an app, what will happen now, generally, of course? You will click on the icon. Now the Fabric side, instead of the UI manager, will load the native side, not the native modules yet. The JavaScript side will do its magic without talking to the bridge. It will load all the React components and relevant Turbo modules. The Fabric side, because JavaScript has a reference to the Fabric side, it will call create nodes without any JSON async request in the native side. It will create the shadow nodes. It will use the Yoga to calculate the layouts, and you have the app. Everything's supposed to work a lot faster, smoother, even safer. So like I told you, this was the architecture before, and this will be the change. So the main change here is the JSI. If you want to start reading about it or make it sharper in your mind, I would start from the JSI concept. So before we finish the lecture, I want to give you some takeaways specifically about the Fabric, not about the lecture. After that, I will give about the lecture. So 4 things I want you to remember from the project Fabric, the new architecture of React. First, JSI is the new glue between JavaScript and native. Forget about the bridge, JSI. I know it's sad for some of you. I see someone crying there in the second corner, but don't worry, it will be better. You have the link core. It's better from the community. It's launching faster. And I think it's a good opportunity of some of you, the React Native developers here, to try contribute their own code. In addition to it, you have static types. You can pre-configure the types, so the native will be a rail to the JavaScript side. And the turbo modules are lazy loaded. Instead of loading everything, it's preloaded. By the way, like you can write custom native modules by yourself, like the calendar manager that I showed you. You can also write turbo modules by yourself. It's still not like mature enough now, but you can read about it and see the code and like get ready for it. Who knows? Maybe you will be here and lecture about turbo modules next year in ReactNext, if you'll be one of the first people that do it. So maybe you are interested what are the release date of all these new changes. So the JSI, like I said, it's already on the master of React Native since the version I said. You can already find it, and most of the documentation is there, but not all of it. Link core is a process that already started. They already started taking out some of the libraries, and you can see in a very transparent way what are the future libraries that they want to take out from the link core, from the main core. And talking about Cochin, turbo modules, and Fabric, this will be ready maybe in the last quarter of 2019, maybe the first of 2020. They do not give you an official date. They said it's supposed to happen gradually, step by step. So it will take time, but you can follow it. It's very transparent through their GitHub. OK, so the takeaways that I wanted to take from the lecture itself is also 4, because I wanted to put some nice notes here. So first, ask yourself before choosing. React Native is great library to use, but you also have Flutter. You also can write native code. Maybe Cordova is a lot fit for you. If you read a little bit about the architecture and understand what its purpose, maybe you will know what to use. But don't use React Native only because it's cool and popular and stuff, because it's not so easy and it's not fit to anyone. In addition, there is never real magic. If you want to understand something, deep diving to it, it will take you time, but it's very fun. Take a coffee or 2 or 3 or 5, and then read everything. I can tell you that like I read a lot. I read like hundreds of posts, and it took me a couple of days, but after that you understand the architecture better, and it even makes you, I think, a better developer that understand the code more, that understand bugs and like surprising stuff that happens to you on the way. And in addition, like I told you before, try writing your own turbo modules in the future. So from this lecture, like I told you, I read a lot of posts. I took some 5 or 10 posts that you can, in 2-3 hours, can read and watch some videos, and you will understand the new architecture a lot better, really a lot better. And if you want some more links, feel free to email me, but 2-3 hours, you will understand the architecture a lot better than now. Of course, 30 minutes of a lecture is not enough. You need to sharpen it more. You need to practice it to read. Those are some of the links that I would start with. If you want to email me, feel free to email me here, Chen Feldman, gmail.com. Follow me on Twitter. I will upload the slide today or tomorrow, or Medium. I'm going to write some post about it, about the new architecture. So thank you very much. Now we'll do a flip report.